Hey guys, so today we're going to be dealing with Introduction to Probability. If you wanted something that was more specific, then you'd have to go watch the other videos, or you'd have to ask me to make a video on a particular question. So let's start with what probability is. Probability is also called chance, or what is the chance of something happening. Probability can be written in a number of ways. Normally, when we're verbally talking about probability, we use words such as that is impossible, or that has an even chance, or that is likely to happen, things like that. We can also show probability in either a percentage, a fraction, or a decimal. The most common form of showing probabilities is as a fraction, and the reason why we show probability as a fraction is because it allows us to see the sample space and the possible outcomes, and I'm going to explain to you what they are in a second. So let's start with sample space. Now, sample space is all the possible outcomes that could occur. That means we have to look at, okay, we want to do something, what possible outcomes could occur? So let's start with a standard die or dice and see what possibly could happen if I roll that dice. So if I roll that dice, what possible outcomes or what possible results could I have? I could either roll the dice and get a 1, a 2, a 3, a 4, 5, or 6. That means my sample space is 1, 2, 3, 4, 5, 6. They are all of the possible outcomes that could occur. Let's move on to another realistic question in regards to sample space. What is the sample space of the days of the week? So if I was to choose one day of the week randomly out of a hat or whatnot, what possible outcomes could I have? So if I was to choose a random day of the week, it could either be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. Similarly, if we were doing the sample space of the seasons in a year, you have 4 seasons: summer, autumn, winter, and spring. Let's move on to simple probability. Now, when we write probability, as I mentioned before, it can be written as a fraction, decimal, or percentage, or it can be written as words as well. But for mathematical concepts, we write them as a fraction normally. So how do we write it as a fraction? Here you'll see the structure of how we write probability, and you'll see P, open bracket, A, close bracket. That means what is the probability that event A will occur? Now, event A will change depending on what the question is, but the P stands for probability, and whatever's in the brackets is what we're looking at. Now, after that, we write the answer as a fraction. At the bottom of the fraction, or as the denominator, we have the number of outcomes in the sample space. As we discussed, all of the outcomes of the sample space. So if we were using dice, we would have 6 different outcomes. If we were doing days of the week, we would have 7 outcomes. If we were doing seasons, we'd have 4 outcomes. And on top, we have the number of favorable outcomes, or the number of times that probability event can occur. Let's do a simple question here. We have a standard die, and we're looking at the probability that a 6 can occur if I roll that die. Now, this is quite simple, but the first thing we do is we write our sample space. We have 6 options, so I'm going to write 6 as a denominator, and in the numerator, I'm going to write how many times my event can occur. And the probability of rolling a 6 can occur once, so my probability is 1 out of 6. The next question says, what is the probability of rolling an even number? Now again, we start with our sample space, and our sample space is 6, so I put that as the denominator. And how many even numbers do we have between 1 and 6? We have the number 2, the number 4, and the number 6. That means there's 3 different options that can occur that are even numbers. So I have 3 number of favorable outcomes. Whenever we write a probability as a fraction, it is very important that you always simplify that fraction to the most simplest form. If you don't know how to simplify a fraction, the easiest option is to put it in the calculator and press equals, and most normal Casio calculators will automatically reduce it to its most simplest form. So if we put 3 over 6 in the calculator, that will simplify to 1 over 2, or half. We know, logically thinking, that it is a 50-50 chance, or an even chance, that we will get an even number. Let's move on to cards for probability. Now, in most probability questions for mathematics, we use a standard deck of cards to show or to test probability. The reason why we use a standard deck of cards for a lot of probability questions is because it's an internationally recognized set of standards. So a standard deck of cards has 52 cards, and that's very important to remember that 52 is our sample space, because in order to write the probability, you need to write the denominator as a sample space, and 52 is a standard deck. Now, please understand that a standard deck of cards does not include the jokers. A standard deck of cards only includes the 4 suites, or the 4 different categories of cards. Now, the first category of cards is your diamonds, and your diamonds are red cards. The second category is your hearts, and your hearts, again, are red cards as well. Your third category of cards is spades, and your spades are black cards. And your last and final category of cards is clubs. So you have 4 suites or 4 categories of cards. Now, each of these categories have 13 cards. Each of these categories have 13 cards. What are these 13 cards? So each diamond, heart, spades, and clubs all have an ace, and then they have 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, they have 3 picture cards. They have Jack, Queen, and King. So in total, each of these suites has 13 cards. The ace, my apologies. The ace represents the 1. After the ace, then we have the 2. So it's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So the ace represents the 1. That in total there is 13 cards. How many picture cards do we have? We have 3, the Jack, Queen, and King. They're called picture cards because they are represented using an artistic impression of a Jack, a Queen, and a King. So remember, each suite or suit has 13 cards. That means that the diamonds there's 13 diamonds, 13 hearts, 13 spades, and 13 clubs. Let's go on to a probability question for using cards. Now it says, what is the probability of getting a king? Now let's start again by simply first putting our sample space. Our sample space is 52. How many kings do we have? We have a king of diamonds, a king of hearts, a king of spades, and a king of clubs. So we have 4 out of 52 is our probability of a king. Now, whenever we have any probability questions, remember it is very important that you simplify the fraction. And 4 out of 52 is simplified to 1 over 13. Now, let's have a look at the next question. It says, what is the probability of getting a club? Now, we know each suite, there is 13 cards in each suite. So there are 13 clubs. But we're going to start with writing our sample space, which is 52, all our possible outcomes, and there are 13 clubs. We can simplify this as 1 over 4, or a quarter. There is a quarter chance of getting clubs. Next question says, what is the probability of getting a red card? Now, we know that diamonds and hearts are both red cards. So there's 13 diamonds and there's 13 hearts. Again, first start by writing your sample space. 13 plus 13 is 26. So there are 26 red cards. Simplifying this fraction, we get a half, or 1 over 2. The next one says, what is the probability of getting not a 3? Now, we call this in probability complementary events, or events that are opposite to what normally happens or what we don't want. So the complementary event of 3, what is the probability of not getting a 3? So let's start by writing our sample space down first, which is 52. Now, how many 3s do we have? We have 3 of clubs, 3 of diamonds, 3 of hearts, and 3 of spades. We have 4 3s within our deck. So if we don't want to get a 3, we do 52 minus 4, and we get 48. There are 48 cards in that deck which are not a 3. So the probability of not getting a 3 is 48 out of 52. And when we simplify 48 out of 52, we get 12 out of 13. that means that the probability of not getting a 3 is 12 out of 13. Hopefully this helped you. If you have any further questions, please ask.